Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on Laplace transformation, lecture number 3, which will include first and second shifting theorem, change of scale property with their examples. First, translation or shifting theorem statement. If Laplace transformation of ft equal to small ft, p greater than 0, then a Laplace transformation of e to the power at ft equal to function of p minus a. Here we have added e to the power at with ft. So, and change in right side is in place of p is p minus a. Proof. Since L ft equal to 0 to infinity e to the power minus pt ft dt, LFT equal to small fp equal to 0 to infinity integration e to the power minus pt ft dt, replacing p by p minus a in both sides. We get f p minus a equal to 0 to infinity e to the power in place of p, p minus a ft dt equal to 0 to infinity e to the power minus pt e to the power at ft dt equal to 0 to infinity e to the power minus pt. We take this e to the power at ft in a single bracket dt. Here this is the Laplace transformation of e to the power at ft. We may write L e to the power at ft. So we get the result L e to the power at ft equal to f p minus a. This is the first translation or shifting theorem. Now we give an example. Find Laplace transformation of e to the power minus t square. Let ft equal to t square implies that L ft equal to Lt square this is equal to gamma function 2 plus 1 by p to the power 2 plus 1 equal to gamma 3 by pq equal to, this is factorial to pq equal to 2 by PQ. Let this is FP, function of P, small f. We know that from first shifting theorem, L e to the power at ft equal to fp minus a. Here in place of a we have minus 1, implies that L e to the power minus t ft is t square equal to, in place of a we write here minus 1, in right side we also write in place of a minus 1 equal to fp plus 1. Since fp equal to 2 by p cube, so this will be 2 by, in place of p plus 1, p plus 1 whole cube. This is the required result. Now we shall prove the second shifting theorem statement. Let Laplace transformation of ft equal to small fp and function gt equal to ft minus a when t greater than a and value of gt equal to 0 when t less than a. Then second shifting theorem says L Laplace transformation of gt equal to e to the power minus ap fp. Now we shall prove this. Prove L gt, Laplace transformation of gt equal to 0 to infinity e to the power minus pt gt dt equal to 0 to a limit integration e to the power minus pt gt dt plus a to infinity e to the power minus pt gt dt. Here value t is the variable, value of t is between 0 and a, means less than a. In that case value of gt equal to 0. So we write 0 to a e to the power minus pt into 0 dt plus a to infinity integration e to the power minus pt. This is the value of variable t between a and infinity, means greater than a, t is greater than a, at that time gt equal to f t minus a dt equal to a to infinity, first integration is 0 e to the power minus pt f t minus a dt equal to a to infinity integration e to the power minus pt f t minus a dt. This is number 1. Let t minus a equal to x implies that t equal to a plus x dt equal to dx when t equal to a, then x equal to 0 and t tends to infinity, then x tends to infinity. Now one may be written as L GT equal to, we take variable x here, so lower limit will be 0 and upper limit will be infinity, 0 to infinity, as x equal to 0 and x equal to infinity. E to the power minus p, value of t is a plus x, f t minus a means x, dt equal to dx equal to 0 to infinity, e to the power minus ap, e to the power minus px fx dx. We may take out e to the power minus ap outside, as this integration is with respect to x, so it is free from x. So we may write e to the power minus ap, 0 to infinity, this is x, e to the power minus px fx dx. This equal to e to the power minus ap. This is the finite integration. So we may change the variable x by t, 0 to infinity, e to the power minus pt ft dt. So this will be equal to e to the power minus ap. This is Laplace transformation of ft. So L ft equal to e to the power minus ap, L ft equal to small fp. So L gt equal to e to the power minus ap fp. This is the second shifting theorem. Here example of second shifting theorem. Given that gt equal to cos t minus 2 pi by 3 when t greater than 2 pi by 3 and gt equal to 0 when t less than 2 pi by 3. If we shall have to find Laplace transformation of gt, let ft equal to cos t. Then ft minus 2 pi by 3 equal to cos, let ft equal to cos t, then ft minus 2 pi by 3 equal to cos t minus 2 pi by 3. So here gt equal to ft minus 2 pi by 3 in place of a equal to 2 pi by 3. Now LFT equal to L cos t equal to P by P square plus 1 square equal to P by P square plus 1. This is small fp. Now, according to the second shifting theorem, LGT equal to, L gt equal to e to the power minus ap fp. Here a equal to 2 pi by 3. So we write e to the power minus 2 pi by 3 fp equal to p by p square plus 1. This is the required value of LGT, where GT is given cos t by minus 2 pi by 3, t greater than 2 pi by 3, GT equal to 0, t less than 2 pi by 3. So this is the required result of LGT. So the result is e to the power minus 2 pi by 3p, p by p square plus 1. This is the required result. Now we will discuss about change of scale property statement. If LFT means Laplace transformation of function of t equal to small fp, then a Laplace transformation of function of at equal to 1 by a small f p by a. Since L f at equal to 0 to infinity integration e to the power minus pt f at dt equal to, here f at, let this is 1, let at equal to x implies that a dt equal to dx implies that dt equal to dx by a, and t equal to x by a. Here let L f at equal to, now integration, we select integration when t equal to 0, then x equal to 0, and for t tends to infinity, x tends to infinity. So 0 to x, 0 to infinity for the value of x, e to the power minus p, value of t is x by a, fx dt means dx by a equal to 1 by a, 0 to infinity integration e to the power minus p by a x fx dx. This is the definite integration. So we may change the variable x into t, 1 by a, 0 to infinity, e to the power minus p by a, t, ft, dt. Here LFT equal to small fp. Here we have function in place of p we have here p by a. So we may write 1 by a f p by a. In place of p, here we have p by a. So this is called the change of scale property. Now we give an example. Now we have to find the Laplace transformation of sin h 3t, sin hyperbolic 3t, by using change of scale property. Let ft equal to sin ht and f3t equal to sin h3t. Lft equal to L sin hyperbolic t. This is equal to 1 by p square minus 1. This equal to fp. Let by scale property Lft Fat equal to 1 by a fp by a, implies that L f3t equal to 1 by 3 fp by 3, implies that L f3t is sin hyperbolic 3t equal to 1 by 3, fp equal to 1 by p square minus 1. So we write here 1 by p by 3 whole square minus 1 equal to 1 by 3 1 by p square by 9 minus 1 equal to 1 by 3 into 9 by p square minus 9 equal to 3 by p square minus 9. This is the required solution. Now we solve some problems based on general formula, first shifting theorem, second shifting theorem, and change of scale property. Problem number 1. Find Laplace transformation of ft when ft equal to 4, when t lies between 0 and 1, 3 when t greater than 1. Since L Laplace transformation of ft equal to integration 0 to infinity e to the power minus pt ft dt. Now we divide the interval from 0 to 1, then 1 to infinity. So we divide the integration from 0 to 1 and then 1 to infinity. When value of t between 0 to 1, then value of the function of t is 4. So we put here 4. When value of t lies between 1 and infinity, then value of ft equal to 3. Now we integrate, we get this result. We integrate this also, taking 4 and 3 outside, putting limit 1 then 0, we get this. Here also similar, putting value of t equal to tends to infinity and 1, we get this result. So we get e to the power minus p here, e to the power 0 here, e to the power 0 means 1, outside 4 minus 4 by p, here 3 by minus p, is minus 3 by p. When t tends to infinity and p greater than 0, then value of e to the power minus pt equal to 0, and here e to the power minus p. So by calculating we get 1 by p 4 minus e to the power minus p. Now we shall solve the second problem using first shifting theorem. The problem is e to the power minus t 3 2t minus 5 cos 2t. Let 3 sin 2t minus 5 cos 2t equal to ft, and LFT, L this. Since Laplace transformation is linear transformation, so we may write 3L sin 2t minus 5L cos 2t. Laplace transformation of sin 2t equal to 2 by p square plus 2 square. Laplace transformation of cos 2t equal to p by p square plus 2 square. By calculating 6 minus 5p by p square plus 4. Let this is small fp. Now from first shifting theorem we know L e to the power at ft equal to small f p minus a. So in place of a we have minus 1 e to the power minus t here, and ft equal to 3 sin 2t minus 5 cos 2t equal to f p minus a is minus 1, so minus 1, so f p plus 1. Here in place of p, if we write p plus 1, here we will get 6 minus 5p plus 1 by p plus 1 whole square plus 4. So we get this result. Now we solve problem number 3. We have to find Laplace transformation of t cube e to the power minus 3t. It is also based on first shifting theorem. Let ft equal to t cube, LFT equal to LT cube, LT cube equal to gamma 3 plus 1 by p to the power 3 plus 1. Gamma 3 plus 1 is the factorial 3 and p to the power 4. So 6 by p to the power 4. This equal to fp. Let. Now since from first shifting theorem L e to the power at ft equal to fp minus a, here e to the power at means e to the power minus 3t and ft equal to t cube. So in place of a we get minus 3, so here we put in place of a minus 3, that is fp plus 3. Here in place of p, if we write p plus 3, then we will get 6 by p plus 3 to the power 4. This is the required result. Now we shall solve a problem. This is problem number 4. Based on second shifting theorem. Here given that gt equal to e to the power t minus a for t greater than a and 0 for t less than a. Let ft equal to e to the power t, then ft minus a equal to e to the power t minus a. Here ft minus a and here 0. In this case the second shifting theorem is applicable. So firstly we find LFT equal to L e to the power t equal to 1 by p minus 1 equal to Fp left. Now LGT according to the second shifting theorem is e to the power minus AP Fp. Here A is same as A, so this remains the same, e to the power minus AP, and value of Fp is 1 by P minus 1. So this is P minus 1. This is the. Thank you for watching my video. If you are satisfied with my presentation and contents, please click on like button and do subscribe my YouTube channel.